Hello viewers, in today's session we are going to discuss another important and very conceptual problem from integrals, right? So here we have to evaluate this integral from 0 to 1, and here the integrand is x times 1 minus x raised to 4, and the whole power is 5 over 2, right? So here we have to evaluate this integral using the concept of beta and gamma functions, right? So we'll make use of some important results from beta gamma functions to evaluate this integral. So let us first make the use of substitution method, and then we'll apply the different relations or different concepts from beta gamma functions. So let us start. So let us call this integral as I, and let us make the substitution that is t is equal to x raised to 4. So here I will take t is equal to x raised to 4. Now differentiating t with respect to x, we have dt over dx is equal to the derivative of x raised to 4, and using the power rule for differentiation, we have the derivative of x raised to 4 is 4 times x cube. So now from this relation we have x is equal to t raised to 1 by 4, and taking the value of x is equal to t raised to 1 by 4 over here, we have 4 times, then we have t raised to 1 by 4 raised to 3. So this is 4 times t raised to 3 by 4. So dt over dx is equal to 4 times t raised to 3 by 4. So now dx can be written as dt over 4 times t raised to 3 by 4. So this is equal to 1 by 4 t raised to minus 3 by 4 dt, right? So for dx we can take the value as 1 by 4 t raised to minus 3 by 4 dt. So now here the limits of integration vary from 0 to 1. So let us change the limits accordingly. So when x is equal to 0, which is the lower limit, so we have the value of t as 0 raised to 4. So here I will take x is equal to 0. So t is 0, and when x is equal to 1, 1 is the upper limit. So t is 1 raised to 4, that is simply 1. So when x goes from 0 to 1, t goes from 0 to 1. So now let us rewrite this integral in terms of t. So now I is equal to integral from 0 to 1. For x we can write t raised to 1 by 4, and here we have 1 minus t, and then we have 5 over 2, and for dx we can write 1 by 4 t raised to minus 3 by 4 and dt, right? So now we'll simplify this expression, and we have 1 by 4 outside the integral, and here we have 0 to 1, and here we have t raised to 1 by 4 and t raised to minus 3 by 4. So we have 1 by 4, and here we have minus 3 by 4, and here we have 1 minus t raised to 5 by 2, and this is dt. So now we can write 1 by 4 and 0 to 1, and here we have 1 minus 3 is minus 2 divided by 4, so this is minus half. So we have t raised to minus half, and this is 1 minus t raised to 5 by 2 dt. So our integral I is now 1 over 4 0 to 1, and then we have t raised to minus half, right? Now see, minus half can be written as half minus 1. So here we write half minus 1, and then we have 1 minus t raised to 5 by 2, and 5 by 2 can be written as 7 by 2 minus 1, because 7 by 2 minus 1 is 7 minus 2 over 2, that is 5 over 2. So here we can write 7 over 2 minus 1 dt. So our integral I can now be written like this. So now here let us define the beta function. So the beta function is defined as beta of m comma n as the integral that is 0 to 1 x raised to m minus 1. Then we have 1 minus x raised to n minus 1 dx for m and n greater than 0, right? So now we can see that this integral is similar to this one. So here we are taking the variable x, and here the variable is t. So now if we compare this integral with this one, then this is a beta integral, and the value of m is equal to half, and the value of n is equal to 7 over 2. So this 1 over 2 is our m, and this 7 over 2 is our n, right? So m is half, n is 7 by 2, and this integral is known as the beta function or the beta integral. So we can now write I is equal to 1 by 4, and here we have beta of m comma n. M is half, and n is 7 over 2. So now our aim is to find out the value of this beta function by converting it into a gamma function. So the relation between beta function and gamma function is given by beta m comma n, and we have here gamma of m, then gamma of n divided by gamma of m plus n. So this is an important relation connecting the beta function and gamma function. So here beta of half comma 7 by 2 can now be written in terms of gamma function as gamma of half, then gamma of 7 by 2, and divided by gamma of half plus 7 over 2. So now we have to calculate the values of these three terms. So now I can be written as 1 by 4. Then we have gamma of half. Gamma of half is equal to square root of pi. So here we have square root of pi. Now gamma of 7 by 2 can be expanded, or it can be written in terms of square root of pi by using this relation, that is gamma of n plus 1 is equal to n times gamma of n, right? So gamma of 7 by 2 can be written as gamma of 5 by 2 plus 1. So now we have gamma of 5 by 2 plus 1, so this is our n. So we have gamma of 7 by 2 as 5 by 2 times gamma of 5 by 2. So now gamma of 5 by 2 can further be written by using this relation. So we can now write 3 by 2 plus 1. 5 by 2 is 3 by 2 plus 1. So we have 5 by 2. And then using this relation, now n is 3 by 2. So here we have 3 by 2 times gamma of 3 by 2. And this is 5 times 3 is 15, and here we have 4, And then gamma of 3 by 2 can be written as half plus 1. So again, using this result, we have n is equal to half. So we have 15 by 4 times half and gamma of half, right? So this is now equal to 15 over 8. 4 times 2 is 8, and gamma half is equal to square root of pi, right? So gamma of 7 by 2 is equal to 15 over 8 times square root of pi. So now I is 1 by 4, gamma half is square root of pi, and gamma of 7 by 2 is 15 over 8 times square root of pi, right? And in the denominator we have gamma of half plus 7 by 2. So half plus 7 by 2 is 1 plus 7 over 2, that is 8 over 2, that is 4. So in the denominator we have gamma of 4. So this is gamma of 4. Now using this result, that is gamma of n plus 1 is equal to gamma n factorial, and here gamma of 4 can be written as gamma of 3 plus 1, that is 3 factorial. So 3 factorial is 3 times 2 times 1, that is 6, right? So here n is equal to 3. So in the denominator we have that is 6. So I is now equal to 1 by 4, and gamma of half is square root of pi. Gamma of 7 by 2 is 15 over 8 times square root of pi, and gamma of half plus 7 by 2, that is gamma of 4, that is equal to 6. So now we can simplify this expression. So square root of pi times square root of pi is simply pi, and in the numerator we have 15, and here we have 4 times 8 times 6, right? So now we can cancel 15 and 6. So this is 3 times 5, and this is 3 times 2. So we have 5 pi, and here we have 4 times 8 is 32 times 2, that is 64, right? So the value of this integral is equal to 5 pi over 64. So viewers, the value of this integral I can be obtained by making use of the concept of beta and gamma functions, and the value of this integral is 5 pi divided by 64.